Okay, no pressure. Okay.
All right, I'm ready when you are.
It's like, oh, that's, okay. Hello everyone. Today we're going to be talking about Git. Anyone here familiar with Git? Can I get a show of hands? A little bit, all right. Okay, that's good, It's important. Git's really important, so we're going to be talking about it. All right, so anyone here, since for the people that are familiar with Git, do you guys understand what version control is? To a general degree? I can talk about it a little bit. So version control is practically a system. It's used to give teams visibility to the code history. So when you're working on a large-scale project, you'll go through multiple changes. With the version control system, you can monitor and easily access that whole code history to see all your changes. And it's a great source. It's a single source of documentation. So it's a great way to, again, see your changes and then have a good idea of what you've worked on, what you need to work on, etc. Within the industry, now if we're talking practical, at work or at a big company, it is arguably the way to do work within teams. Version control is extremely critical, and it's the way that most large projects are actually maintained. So in case you don't know, this is a very important thing. Git is actually a form of version control. There are other systems, but Git is the most popular form of version control. And it was developed by Linus, who's also the same person who developed this. You want to do this? Sure.
Okay, so when we're talking about version control, obviously it's important to understand why that is important and where it comes into play. So one of the biggest things that it allows you to do is have multiple developers working on the same thing at the same time, but not overwriting each other's changes. So it's not the same as when you're in the media box and you have multiple people editing and you're all at the same time, you can see each other's changes. But that also probably wouldn't be the most useful thing for editing code. So it's a different system. It's not necessarily simultaneous editing that's synced across everyone, but it allows different people to edit different files without overwriting what other people have done, or getting in other people's way. It allows you to keep track of the changes in the repository, so you'll be able to see all of the commits, all the changes that have happened to the code base, which is obviously really important. And by extension, you can easily roll back changes if something happens. Something like an error that you didn't account for ends up happening after you've already pushed your changes. You can roll it back. It allows you to keep track of who has done what, who has committed what, who's changed what, if somebody deleted something, which is important for accountability. And it also enables you to test features without changing the code base that you have deployed. So if you have a production app and you also want to test a feature, you don't have to use the same code base and write everything. It allows you much easier access to be able to test out a feature.
All right, yeah, so as you mentioned, there's a lot of benefits to Git and version control as a whole. We'll be talking through a few particular concepts of Git, and that do actually apply to other version control systems as well. But these are the 5 main concepts. So there's branches, there's commits, which are applied to branches. There's the staging area, which is a pretty big part. There's the whole concept of merging, which applies to branching. And there's the repository, which we talked about. So what is the repository? A repository is the most basic element of Git. It's practically where you store all your code, all your files, and this is also where your Git version control history is maintained. So this is where all the changes that you made to your code are maintained in a file. It's typically stored in a cloud. If we're working in a modern day environment, it's typically stored in the cloud with services like GitHub, which is a hosting platform for repositories. And again, this enables you to work collaboratively. So a repository is practically the place where your code is. Multiple people can access this repository through services like GitHub and work on it together. Yeah, for our projects ourselves, we have individual repositories. So Unibot has its own repository, our club website has its own repository, Unipatch has its own repository. This new project we're working on called Immersion also has its own repository. So they're independent code bases specific to the project itself, and multiple people can work. Go next slide. Perfect. So what is a branch? A branch extends from the concept of a repository. So a branch is a separate piece, it's a separate version of your base repository. What it enables you to do is you can work on different features and different parts of your project separate from the production code. And what I mean by production code is base code that you will use that is potentially deployed to a server or deployed to a service or practically faced by your customers. So by having a branch, you can work on individual parts independent from that and without risking modifying any of the code, breaking any features, any of that stuff. So branches are really useful. They're the kind of bread and butter for Git. And you can think of them like a tree branch. So if you think of a tree, the root part of the tree can be the original part, the base branch or the master branch. And you can have individual branches of that tree represent individual features, different things you're working on that extend into other parts. Now, the main difference between a tree and Git trees is that you can see in this diagram, when we're done working on a feature per se, we're working on, say, branch, I don't know, a feature branch or a bug fix branch. Once you finish working on that feature, it's typical to re-merge that branch. So that branch goes back into your production code, and it eventually merges in and updates your production code so that when you finally deploy your new code with all your new features, that branch no longer, or ideally no longer exists unless you continue adding to it. The main concept is they reconnect back to your production code. That's the concept of branches. So if we go to the next slide.
And then we also, so when we were doing the Photos guide, we had you guys switching between the main branch and the starter code branch. That was essentially, it was the same thing, but the starter code branch just had enough to get you going, and then we were supposed to try to fill in everything else. And the main branch had the complete bucket. You can see how that kind of applies.
All right, so let's talk about commits. Now commits stem from the main part of branches. So typically when you work on a large-scale project, you'll have your repository, which we've talked about, your branches, which will be individual to any features or bugs you're working on, and your commits. Now commits are practically just a snapshot of your repository at a particular state. So you might have a feature branch and you're working on A, B, and C features. You could have a commit for, say, I've implemented feature A, and that would be one commit. So you could represent that as a snapshot of the fact that you've implemented that feature into your particular branch or any part of your repository. And what that allows you to do is build something called a commit history. Commit history is practically the basis standard of how individual changes to your code base are managed. So when you look at your commit history, you can see individual changes with messages indicating what you changed in your repository at any given point. And that adds to the whole documentation feature of Git. So you can manage and have documented records as to what you've added or removed from your projects, which is really important. With commits, there's also, with Git specifically, and commits, there's a whole concept of the head pointer. The head pointer is, you can think of it, for people who have taken Computing 1, you can think of it like a traditional pointer, but instead of pointing to something in memory per se, it points to the latest commit in the particular branch. So say if you go into your feature branch and you've made 30 or so commits to your branch, this will point to the latest commit you've made to your branch, and it will point to the latest change. So you can choose to go back and revert to a particular different commit within your version history, but the head pointer always points to the latest change. This is important when we talk about changing branches. So once you change a branch, say you go from your feature branch to your production branch, the head pointer also travels with it. This is a little bit internal to how Git works internally, but once you start debugging some features, sometimes you might face issues with merge conflicts or having large changes in your code not working correctly. The head pointer is something that's really important to know. It's a little technical for an introduction concept, but it's still very important. We'll go to the next slide. So we can think of this staging area. Staging area is a very important concept. So this connects to the other things we've been talking about. So this is your repository. This is your working directory. So this can be perceived as your raw code. So if you're in a particular branch and you're working on a few changes, once you decide to make a commit, the whole process is perceived like this. So what you do is you stage your files. Staging means you indicate that I've made changes to files A, B, and C, and I'm ready to specify that I want to commit them. By committing, it means I'm committed, I'm done. These changes are set, and I'm ready to put them onto the repository. I'm ready to make a record of them. So if we go to the next slide. So when you decide to commit your changes, they get marked into your directory, which means that they've had a record made. And it's more explicit because when you make a commit, you specify a message. That message indicates what your commit is about. Typically, it's 1 or 2 lines, add a new feature, change the color of a button, or it could be something huge like added an AI LLM to our website, something like that. But this commit message and this commit change goes from your staging area, which is right here, into an official record marked as a commit. So it's important you understand these 3 parts. This is your raw code, this is your staging area, which indicates you want to declare that you've made changes to these files. And commit indicates, yes, I've declared that I've made changes to these files, this is what these changes are. Go ahead and mark them. That's what this allows you. You can go to the next slide. I think that's it, but is that it? Oh, this is, okay, perfect. Sorry, I didn't notice that. So if you want to change your branches, say you're done working on features A, B, and C on your feature branch, and you're ready to put it back in your production, what you do is a checkout. Checkout allows you, now checkout is different from merging, but checkout is the fundamental procedure of changing branches. So if you say want to change into a new branch with a different feature, and you don't want the same code to carry over from the branch you were just working on, you can check out from your current branch into a different branch. It's a pretty basic command. It's a very basic concept as well. You change branches. The terminology is called checkout. If you go to the next slide. So merging. Now this is going back to the whole merging your features. So you're done working on your feature branch. You're ready to merge it into your master branch. So that means you're ready to put it into production. Your customers, whoever it may be, are now ready to experience the changes you've made, added the features you've added, et cetera, et cetera. So when you merge, your head pointer changes from your branch that you're at into the branch you're merging into. It's a little technical. You don't really need to know it from an introductory perspective, but it's important to know that that happens. One thing that can happen when you do merges is called a merge conflict. What this means is you've made conflicting changes to the same region in the same file between 2 branches, and Git doesn't know how to resolve them. So say you have 3 lines of code on lines 5, 6, and 7 in a file, and you're merging it into another branch that has different lines of code within those same 3 lines, 5, 6, and 7 in that same file. Now Git doesn't know what to do with the changes you've made or what the changes exist. That's called a merge conflict. And you have to manually specify to Git how to merge those. But that's a very common thing when you do merges, so it's important to know. Yeah, that's about it. That might have been a little technical, but that's the primary concepts of how to work with Git. Merging, branches, commits, the staging area. These are all very important concepts and very fundamental to Git. So once you get working on our club projects, or even the activities we've been working on, PhotoSky included, this is practically the format you're using. This is called version control system, and Git is a form of version control. Thank you. I think we can do that tutorial later.
So
Oh, yeah.
Have, any questions?
Yeah, but we could do questions if anyone's curious.
About Git? Yeah.
Sure.
Oh, question here.
So say you destroy your local version of your
Oh.
repository, does that affect the remote end?
That's an excellent question. We could take GitHub for an example as a place to host your repository. If you've cloned your repository, cloning, I'll briefly explain what cloning is, but pretty much it means to make a copy of a remote repository on the cloud somewhere and put it locally. So say if you decide to delete that repository, completely destroy it, or you just don't want it anymore, it gets corrupt, something happens to it. Because your core repository is stored on the cloud, assuming you made no changes to your base repository, your code should not be lost. Your main code should not be lost. Excellent question. Any other questions?
Let's see. Question about main branch and kind of maybe somewhat related, but the concept of pipelines. What is significant about the main branch or master branch, and why is that used, and how does that lead to using pipelines to automate deliver software to your clients.
That's an excellent question. So, why is the main branch so important? As I mentioned earlier, the main branch can be perceived as your production code. So it's the customer-facing code. That's the branch that contains all the code that gets compiled, built, interpreted, however, to be used and given to the customer. So because that's all in the main branch, it's really important that you protect your main branch and you keep it separate from some other experimental stuff you're working on. And relating to the topic of pipelines, because it's the main branch and you can assume certain things are very specific and streamlined with the main branch, you can do a lot of automation. We actually do this with a lot of our repositories for the club. So if you take, say for example, our club website, our main branch has a whole procedure for doing pull requests. Pull requests is a GitHub thing, but it's the format of requesting someone to merge your changes into the master branch. There's a whole pipeline built in so that when someone requests that, not only does the code get pulled and everyone, someone comes in and checks and reviews your code, but it also automatically gets deployed. So it gets compiled, gets checked, is this code valid? You could think of it like a C program. GCC is run on your code and it checks, is this a valid program, can it compile? So you can build automations to pretty much have GitHub or any platform per se do that for you. So you can relieve the headache of making sure did someone write good code or bad code. So that's an excellent question, yeah. Because of the main branch, you can write a lot of pipelines and automations to improve the quality of your code.
Maybe as an additional note, typically in production systems, you never work on the main branch directly. The main branch is sort of kind of your source of truth. It's sort of you're not touching it, you're not allowed to touch it, right? You're working on a feature branch, for example, like you develop a feature branch, and the idea is that you have sort of kind of like some snapshot in time on the feature branch, and you introduce your changes to that. And now that you have your feature branch, which has a copy, you see everything. You see the whole system. You're working on a small piece, right? But you have a snapshot of the whole system, right? And you can now have automation on your feature branch, of course, right? Which means because you want to be able to test your changes, your additions, your features, or your bug fixes on that feature branch. So the automation runs on your feature branch, and then eventually we talk about promotion to main, right? That's the terminology that's often used, right? And then when that happens, then things sort of come together. I mean, one thing that's worth noting, I don't know how many of you have worked on large projects with source control, is that there is sort of kind of like this term merge hell, right? And it's a very true term, and it's something that you most likely will live through. And it happens that if a lot of changes are happening in parallel on different branches, people work on different things, on different features, and now you're trying to bring them all together. The merge conflicts that Rick mentions become not a small problem, they become a huge problem. And they become such a big problem that you will rip your hair out, right? And the only really antidote to that is to merge frequently and to merge smaller changes as often as you can. Right? But the point is that managing collaboration on large projects, GitHub is a super important tool, but it cannot solve the problems that will occur when so to speak 5 people start working at the same time on your car engine, right? It's not going to go well, right? So it's just bear it in mind, right? I hope this makes sense, right? But I can tell you that merging things and building things and source control is a tool that you have to use the right way. There have to be a lot of sort of kind of like rules around it to make it work for your organization. I don't know. Does it make sense?
Yeah, 100%. That's right on.
It's very important to understand.
Just 2 questions. One simple question is, what's the fork and branch? So when you break fork and branch?
Yeah, that's an excellent question. So if we take to the example of GitHub again, a fork is a copy of the repository that you own. So you can think of it like Yeah, that's pretty much what, as I said. So it's a copy of the branch that takes a copy of the code at a particular point and gives it to you. So you are responsible for it, and it doesn't necessarily connect back to the place you copied it from. It'll be marked as something that you source from, but all the changes you make don't necessarily apply back to the source you for it. And opening a new branch is something, as I mentioned earlier, it's within the scope of the repository itself. So when you open a new branch, it's a version of the same repository linked to the same original repository, so that once you make a pull request, it can link back in. You can also make pull requests with forks, so that's still valid. But conceptually, it's treated as a different concept. It's the ownership of the code is more personal with a fork than it is with a branch. So that's an excellent question, but yeah.
And second question is like how get with other cloud platform like AWS, GCP, those can be connected or how?
Oh yeah, excellent. So yeah, we could. So if we talk about UniPath, UniPath is one of our projects that is integrated with the cloud. So you can. So as Martin asked earlier about pipelines, you can incorporate and build a system so that not only your Git code gets linked to a cloud system and they automatically pull changes. Pull changes means they'll take the code the latest code that you have, if there's any new changes to it, and automatically deploy it. So you can add a pipeline that does that for you.
So what would be the main storage system? We have like AWS
Hello.
and then we have.
There's no audio here.
Yeah, so the actual implementation can be a little complex. It can be as simple as a Lambda function and then S3 bucket to store any of the raw data itself. And the Lambda function to pull the changes and then S3 bucket to store the data. Depending on the scope and the other parts of your application, there can be other services involved. Say, for example, the service you build from your code from the S3 bucket and then you compile also works with HTTP requests. So you could add an API gateway there to take your deployed application and start interacting with it from the internet. But yeah, it depends on the scale of your application. Generally speaking, it's a Lambda function and S3 bucket. Excellent question. Any other questions? These are great questions. Yeah.
Are there any differences between the head, master, and the main branches?
That's an excellent question. I'm not completely sure about the difference between master and main. I think, Martin, can you speak a little bit
so
about that?
it used to be master, but GitHub recently, a few years ago, they changed it from master to main to be more, I guess, clear to everyone that it's the main branch. So it used to be known as master, and they're the same thing. They're the same thing. Right? So some code bases still use the master branch. Most newer ones will use the main because that's the default. But they're the same thing.
And going back to your question about head, head is something that's maintained locally when you perform Git operations. So it's a pointer that points to the latest commit within your particular branch. So when you change branches, it points to this. It's more internal.
Could you use this for like local, smaller projects so you could revert from states and anything like that?
That's an excellent, a lot of excellent questions. Yes, you can totally use this locally. So you don't have to use GitHub at all or any cloud provider. If you're working on, say, a Computing 2 assignment and you've got multiple changes and your code just becomes nightmarish and you don't know what you're doing and it's just chaotic, Git can be a really convenient solution to document your changes, have different versions depending on what part of your code you're working on. Say there's a part A, B, and C. You can have branches for part A, B, and C and maintain different parts so that those parts don't conflict with each other, or you can work on them independently. It helps organize your code, and it's a great way to build more reliable, better documented, more robust code as a whole. Yeah, it's a great point. You don't have to use it online. You can use it on your local system. Awesome.
It might be worth, you can briefly explain how Git and GitHub relate to continuous delivery, how they're connected, and what they would mean.
Sure. Yeah. So Git is, as I mentioned, a version control system. GitHub is a cloud-based hosting service for Git repositories. So you can perform Git operations on a GitHub repository that's remote and work with it yourself. And going back to the continuous development and continuous, so there's a concept called CI/CD, which stands for continuous integration, continuous development. So with tools like GitHub and Git, what you can do is you can automate, as Martin mentioned earlier, you can automate your processes of deploying your application, say to the cloud, using a CI/CD pipeline. With solutions like GitHub, you can have these things called GitHub Actions, which enable you to perform particular operations. You can write a script per se, or a deploy script, anything you want, and have particular sequence of operations occur as soon as, say, a new commit or a new merge happens to your main branch. New change happens, new features added. All right, immediately we can go to the cloud and deploy it immediately and have those features available immediately. That's exactly how our club website works at the moment. So you can build these CI/CD pipelines, continuous integration, continuous development. You continuously integrate to that branch. You can continuously develop and deploy that branch immediately with GitHub Actions and any cloud-based solution. Any other questions?
I guess I'd just like to add a comment that this is very fundamental, and you will see it at every company that you go to work for. Unless you unfortunately end up working at an older company that still uses SVN or Mercury or whatever. What is it? Mercurial? Yeah. Older Git version older version control systems. But 99% of everyone, or at least 90% of all software development companies, they use Git or something. Almost all.
Everyone uses some sort of version control. Git is just one of the more popular and more well-known ones.
Yeah.
I would not say it's 99% of everyone uses Git.
I'm exaggerating.
And it's not just programming that you end up using some sort of version control. It's also used in engineering design. It's also used in just general document management.
But this is a core skill that you as a student should know about. And this will help you in your career and whatever future company you end up working for. Extremely useful. And especially like when you're working with, you're computing 1 and 2 and 3 classes, or you're working on a program for homework, and you want to test a different version of the code out. So what you do is, what people end up doing is they create a copy of the file. So you end up with a bunch of these copied versions, like program 1, copy of program 1, copy of program 1. You end up with a bunch of files like that, where it gets kind of confusing to know which one is working, and etc. So that's what Git solves. It solves that problem of having to create a bunch of different files for different versions of your code, where it's all nicely, neatly integrated into this version control system. So very useful to learn. And after the break, we'll go into learning how to use it, hands-on, with a quick tutorial.
Yeah. Maybe the one term that wasn't mentioned is that it's very important that it's the source of truth, right?
Oh yes.
Because that whatever is in your version control system is the source of truth, which means that's what's very important is that the product that's released is based on your version control system, that sort of so you can repeat it. Repeatability is a super important concept, right? Because you need to be able to build that same code as your customer is using it again, potentially with a small change. Right? So you need to know what it is. So your version control system become your repository is your source of truth, and that's very, very important. Right? So because again, all these copied files of program 1 or whatever it is, right? They only live on your hard drive directory, but nobody else sees them, and you don't know what's in there. Right? So now, once you become a part of the version control system, they they have an official stamp on them, and a time stamp. And the other thing that wasn't really talked about is that in reality, this is connected with your task list, with your Jira system, or with your project management system. And so you have every commit is related to a work item, right? So in many companies will not allow a commit that does not have an associated task item in project management, which means it's either a feature, or it's a bug, or it's a customer request, or it's a project request. But it's not just some check-in that you invented, right? Because that's not allowed, guess what, right? So you have to think this through, right? So there's a lot of complexity there to manage that.
Yep, exactly.
And I don't know if we mentioned this already, but the fact that Git is, how it works is it literally tracks every change that you make. So let's say you have a working version one day, you change something, you don't have to, and it breaks everything else, you don't have to remember what you changed because it does it for you.
It's all there in the history.
Yeah. It's all
So
there.
what happens is that in these pipelines that we talked about, if there's a problem that, and maybe the deployment fails for whatever reason, automated tests that are built fail, there's an automated rollback system in there. And it reverts to the last known good version in your source control system. It builds that and releases that, right? So that's another screw that you're going to put on. So fail fast, right? When you roll back, automatic rollbacks. It's a thing of the, it's a beauty when it works, right? Yeah.
It's a nightmare when it doesn't.
I was thinking, the data that we are working, like climate data. So we have like kind of CSV file, could be stations, or could be any like Nexigate file, INSI file we have. So when we have something on data, so how is that? Can we have like all this as a package, like the data also can be uploaded on GitHub, or it's just the script?
Oh, that's a good question, actually. So there is a difference, yes. With large data sets, so one thing that GitHub, well, for Git, that doesn't work too well is like large files. If you have large files, you need to use something that's called GFS, or Git Large File System, I think. What's it? Git LFS, sorry. What's that stand for?
Large files.
Yeah, large file storage. So that's typically what you use to keep track of larger files and large data sets that go through frequent changes. That's why Hugging Face online is very popular to upload data sets and machine learning models and things like that, because that actually uses Git LFS under the hood for you. And GitHub wasn't so good about that in the beginning, but I think they're starting to pick back up again. And so I think it might.
I think on GitHub for a single file, the biggest it could be is probably around a gigabyte.
I think so. For a
I'm not sure how big a repository itself could be, but I know files specifically.
Yeah, there's limits depending on what plan you have. For the free plan, I think the largest repository size was 5 gigabytes. I might be wrong, but
Don't quote us on this, we haven't looked it up.
yeah, I haven't looked it up, but you can see what the.
What people did is people started using source control systems like with as kind of like artifact repository systems, right?
Yeah.
They started to store like photos and videos and other things, the version that's in there. And these systems are not designed to do that, right? So there's other systems that do that, right? But because this system clearly was intended as source control, tracking the changes of source text files, right? And not changing, tracking the changes of 2-hour video files, right?
But to answer that question, yes, there are version control systems designed specifically for large data sets like that, and that's what you should use instead of a service like GitHub for that, or Git. I mean, it can be, and I just don't really know the process off the top of my head, but there are systems designed specifically for that, and that's what people use in production. So, yeah, hopefully that answers your question.
Yeah, one way around this is, by the way, if you think about it, is that you can store your objects in an object store like S3 in AWS, right? And then in Git, you can sort of kind of like, even though S3 has its own metadata management, you can use Git as your source tracking system, and the only thing there is you have a pointer to your S3 with the associated metadata that you track, right? And it becomes a management. Of course, these things can get out of sync and are in trouble, right? But as long as you keep it in sync, that actually works quite well. Does that make sense?
Yeah.
Any other questions? Great conversations we're having. All right. Pizza's arrived.
Yeah.
All right, pizza's arrived, so we can go inside, have some pizza, and then we'll come back in and do a quick tutorial on Git so everyone can get their hands dirty with a little bit of Git.